So you are solving problems by writing, like actually creating the inequality based on the information and then solving the inequality. Tomorrow we're going to move into two variables. So today's like the last day of solving when there's just one variable. So you have to know those steps for solving and being able to write your answer and graph it. You do have this practice to get 80% or higher on before you can move on to other things. So I try not to overplan for this class. I try to only give you things that you can manage, but some of you have managed to fall behind, so we need to get back. So start with this one because this lesson should be the most fresh in your mind and should be the one that, I don't know, you do the best on. And then I'll check in later with questions on the screen, but you absolutely should ask in advance if you are having trouble. But to kind of warm you back up, because not all of you just had algebra, some of you had it like earlier today. Let's look at some of these, which are on your notes, and you will see this on your test. You will see it on your final. So if you could take out your notes from today, because I don't think you'll have all the steps memorized anyway from notes out. And find this last activity that we did not do in the notes today. We're just going to do a couple of them. All right. So looking at these, they each have their own challenges, but what you will see for sure on your tests are things with fractions. So we need to get better at those. So let's start with number 5 and follow those steps we talked about today. What's the first step usually? Distribute if necessary. Do I need to in this one? No. Check if you have any what to combine. Do I have any in number 5 that I need to combine? No, because of the way it's set up. Like if I look at my numerator, none to combine, denominator, none to combine, no other terms on the other side. So no like that. Then you typically have to check to see if you need to move the variable to one side. I only have one in this one anyway, so no need for that. We can go right into isolating it, starting with what is farther from it and getting rid of that first. So for this side, what's farthest from the x? The 3. Look at what math is going on with the 3 and how would I undo it? So to make this, first of all, we have to get rid of this first. To get rid of it, I would multiply by 3 because to break up any fraction, if you multiply by the denominator, it's no longer a fraction. That's what we're going to do. And then it's a rule about whatever you do on one side of the symbol, that's what we're going to do here. So this makes it no longer a fraction. I get 4x minus 1 greater than, because it's a positive that we multiplied on each side. The 3 is positive, so I don't flip it. And then what's negative 1 times 3? And now this is something that I know you guys can solve. I know you can solve it when this is step. So then from there, now it's farther from the x. Adding 1. I'm going to continue this down here because I'm a little bit out of room. I get 4x greater than negative 2. What's opposite of multiplying 4? That on both sides. I did not have to flip the sign at all because at no point did I divide a negative or multiply a negative. What's negative 2/4 become? negative 0.5 or negative 1/2, which matches one of these number lines. Don't shout it out yet. Just look at your number lines for which one is x greater than negative 0.5. All right, table 1, can you tell me? Or which of the number lines on your paper matches x greater than negative 0.5? Do we have multiple number lines where there's a circle on the negative 0.5? Center. A is the only one that even has a circle on the negative 0.5. So that one must be it. But if there were two, then I have to look more closely at the open or closed circles and what way the arrow is going. But for that one, it's actually kind of easy because one with a circle is even A for that. Questions on that? Okay, let's do one more because again, I'm trying to pick ones that look like what you'll see on the test. So we need to get those ones out of the way. We're going to do number 6 next. So think about it yourself. Don't say it out loud yet. Think about what you would do as the first step in solving this one. Okay. So do I need to distribute in this one? Nope, no parentheses, no distributing. Do I need to combine like terms? If you are thinking of making it like this, since these do have the same denominator, you could, like you could do 12 minus x over 5, like you could combine those technically, make it that. You don't really need to in this one, but normally you combine like terms. I do need to move the variable to one side. So what I will do, because I have two x's, one over here and one over there, and this one's in a fraction, like it's kind of stuck, I'm going to cancel out that fraction. How can I make any fraction not a fraction anymore? Not by the reciprocal if I just want to break it up, which is 5. So I'm doing it in order to make this no longer stuck in a fraction, to cancel it out and multiply by the denominator. But it's ruled out like, if I'm doing that, I need to do it now to the whole problem. Kind of like when we did elimination before. It's kind of like that, same principle. So we're going to multiply everything by 5, each term. What does this become? Just 12. Because I have it being times 5 and divided by 5. That cancels each other out. But if you did the math, it becomes 60 divided by 5 is 12. All right, so there's that. It becomes 12. What happens with this? What does this become when I multiply it by 5? Just negative x. That was the whole point of multiplying it by 5, is so that it's not a fraction. It really just is what's in the numerator. The sign is not affected unless you're multiplying by negative, which I'm not. And what's 5 times x? This is much easier to solve now. So when you see a problem on your test that looks kind of gross like this, consider making it not a fraction anymore by multiplying by the denominator to each term. And now it's much easier to solve. Which variable would you move? The negative x. And I do it by adding x, whatever you do on one side. I get 12 less than or equal to what's 5x plus x. Opposite of multiplying 6 is what's 12 divided by 6? Less than or equal to x. And I didn't need to flip the sign at all because at no point did I multiply or divide the thing. That is why we suggest you move the smaller variable, because then it's less likely you ever even have to worry about that. But yeah, I get 2 less than or equal to x. That answer is the hard one. To match it back up to one of the number lines, you can see the number lines better on your own paper. See if you can find the one that would be 2 less than or equal to x. Well, there's 2 options that are even on a 2. So pay attention to how this looks. Would I have a closed or open circle? And what number is bigger, the 2 or the x? So when I'm picking based on my number lines, I have to pick C, because that's the one that has it pointing to numbers that are greater than 50. Okay. Good practice, good exercise. So number 6 would be C, number lines. But the whole point was the math part of it. If you see it a fraction, you can make it not a fraction by multiplying the denominator. Sure. So if you guys want to go ahead and start working on your practice, great. I'm going to do number 1 on this one. So if you care to see something like that, then keep walking. But number 1 on this one was 6x less than or equal to 3x. So do I need to distribute? Do I need to combine like terms? Only like side, like left side, there's no like term. Right side, there's only one term. But no, you don't have it. You do need to move the variable to one side. And which one do we always recommend you move? How would I move the 3x? Whatever you go on one side. Make it cancel on one side. 3x minus 3x is 0. And I don't have anything else here. Normally, like if there was another number here, you could just write that number. When there's nothing at all, you put a 0. Because that's what it cancels out. What, 6x minus 3x? Opposite of multiplying. So we did the moving variable to one side. Now we're just isolating. So opposite of multiplying by 3 is whatever you go one side. What is 0 divided by 3? And notice I did not divide a negative, so I should leave the sign facing the same way it was. That's why we do the smaller one. That way you probably don't have to do this. Good? Okay. And then the one that matches that would be there's only one answer that has a dot on the 0, so that one would have to be that. Yes. Yes. All right, so you guys have the hour to work on your practice from today, lesson 20, and then whatever else you need to get done. That's right now. Okay, so this is today's practice number 2, in case you also would like some help with it. Lynn is solving this inequality. She knows the solution to, I guess, the equation of the same thing is x equals 1. You need to complete the following to show how Lynn can determine whether x is greater than 1 or x is less than 1. And that would be, she can substitute, so plug back in a number greater than 1 into the inequality to see if it's true. So if she did that, so she's plugging in a number greater than 1. Which one is greater than 1? The one on the left or the right? Let's see if it's clear. The one on the left or the right is greater than 1. One on the left. So if she plugs in a number greater than 1 and it's true, then that one must be the solution, the one that says x is greater than 1. If it's not true, then the other one has to be the solution, the one that says x is less than 1. That's what you would do. A weird way to go about it, but I guess that does work. You could treat it like an equation and then just see what direction would the answer. But otherwise, like, you should really just treat it like an equation and only flip the sign when necessary. So like on this one, I would have to subtract the 15 first on each side. When I do that, I get negative x less than negative 1. The x is not fully isolated. What's in front of the x right now? What is it if it's not written? And right now it's a negative 1. The opposite of multiplying the negative 1 would be dividing a negative 1. Right, it's lagging. All right, so we're dividing a negative 1 on each side to fully isolate x. Anytime you divide a negative on both sides, what do you have to do? Flip the sign. So that is the solution, not the other. Questions? Other questions at all? Cameron? Number 3 on this one. Number 3. So a cell phone company is offering 2 texting plans. People who use plan A pay 10 cents for each text sent or received. People who use plan B pay $12 per month and then an additional 2 cents for each text sent or received. So which inequality represents the fact that it's cheaper for someone to use plan A versus plan B? So if I want plan A to be cheaper, the opening of my inequality should face what? If plan B costs less, I should do what inequality symbol? Less than. So even if I like rotate the order or something, you guys put plan B on that side, then the opening still needs to face what's bigger. So we're saying that this is more expensive than plan A. I imagine they probably did expressions for each instead of just plan A and plan B. So let's see. Yeah. Which of the... So they're starting with 0.1x. Does that better represent plan A or plan B? Reread it if you need to. So does the 0.1x represent plan A or plan B? Where it says, so read it again, a cell phone company is offering 2 texting plans. People who use plan A pay 10 cents for each text sent or received. People who use plan B pay $12 a month and then an additional 2 cents for each text. If X is number of texts, then the 0.1x is for plan A or plan B? Plan A. That's the one that said it had to be 10 cents per text. No flat fee, no nothing. So I want it to be 0.1x less than, and that one must be this one. Yeah, no, we can plan A, we can plan B. If we want plan A to be cheaper, then it has to be less than the other. Okay. Then it says, what is the solution to the inequality? So here's the correct inequality we determined. We're going to solve it now. So 0.1x less than 12 plus 0.02x, which, yeah, that makes sense. So do I need to distribute in this one? Do I need to combine my terms? I do need to move the variable to one side. Which one is technically smaller? 10 cents or 2 cents? 2 cents. So I'm going to move that one because it means I probably won't have to deal with the negative later. So I'm going to do that. Whatever I do on one side, I do to the other. So I'm subtracting it to cancel it. I don't need to flip the sign when I subtract. And if these decimals are hard for you, use the calculator. But what's 10 cents minus 2 cents? 10 cents minus 8 cents. Like that. Or again, you can calculator. Look at what's being done to the s and then do the opposite. What's the opposite of multiplying 0.08? So that's what we're going to see next. And we're going to do that on both sides. So by me moving the smaller one, I do not end up having to flip the sign at all. So that's good, because that's the only way it's different from solving equations. Calculate that part. So divided by 8. And that's 150. So x less than 150 is the answer. And that means that at 150 text messages, because that's what x is, so long as they're doing less than 150 text messages, plan A is cheaper. Questions on that one? Questions on others? Amy? Question 3 on lesson 19. Okay, so lesson 19, number 3, pretty similar to what we did today in that thing we did for the warm-up. So we want to pick the graph that represents this. So you can solve it, or you can also try graphing it in Desmos and interpret that. I did teach you that too, to check your answers. But let's practice just traditional solving. Do I need to distribute in this one? Yes, so we're going to do that first. I'm distributing on that side. So I'm going to copy over my left side. I'm not doing anything with the left side yet. And what do I get when I distribute this? Good. So make sure we multiply to both terms. X plus 12 is what we get from distributing. Check if you need to combine like terms. I don't in this one. No like terms here, no like terms there. I do need to move the variable to one side. Which one do we always recommend you move? And how do I cancel it out? But already know one side of the symbol. So then I get 5 plus what's 8x minus 6x less than 12. Now it's just a 2-step. So look at what's being done to the x and start with what's farther. How would I cancel out that 5? Whatever you put on one side. I get 2x greater than 12 minus 5 is opposite of multiplying 2 is that on both sides. And I did not have to flip the sign. When we're talking about number lines, it's probably better to compare when it's a decimal. The 7 divided by 2 is 3.5. We can eliminate all the answers that are not on a positive 3.5. So I'm not going to pick that one. And I'm not going to pick the last one. Yours might be shuffled to make sure we're paying attention. Between these two, which one is pointing at numbers that X can be to make it true? The one that's going to the left or to the right? The left, actually. These would be numbers that are less than 3.5, right? 0 is less than 3.5. Negative 10 is less than 3.5. So you pick this one. Picking what X can be. So yeah, there's that one. Make sure we're not just blindly picking, make sure we're comparing it to what's on our screen. Good on that one. Other questions? Better? Number 1 on less than 10. So we have this inequality, good one to practice, similar to what would be on a test. Although it's not just asking for like, I don't know, X less than or equal to the number. It wants to know which of these values meet that criteria. So I would recommend still solving it and then just seeing, are these X's making it true? So if this is my inequality, do I need to distribute? Do I have any like terms to combine? I do need to move the variable to one side, but notice one of the variables is stuck in a fraction. How can I make any fraction not a fraction anymore? Multiplying it by the bottom number. So if I multiply this entire thing by 2, I'm not changing the answer at all. I'm just making it easier to solve. That's what I'm going to do. Kind of like elimination, if you remember that. Miss Medina.
I had it turned back into Connie. Maybe they accidentally turned it into Genevieve. I don't know. But I sent it back up yesterday. Yes. No problem. Bye. Okay. Oops, I didn't multiply 2 by all of it. I multiplied 2 by this side because then once I multiply it by the denominator, it cancels out the denominator only. I still need to do it to the rest. So what's 2 times 3x? Thank you. 2 times 3x is 6x. 2 times 2 is, and we had to do that because if I'm doing it to one side, I have to do it to both, the whole thing. So now this is much easier to solve. Now I can actually move the variable to one side. So which one would I recommend you move? The smaller one, the 6x, how do I move it? Whatever you do on one side of the symbol. And this cancels out with 7x minus 6x. All right, so now it's just a matter of canceling out that 6, because this made it and just 1x, that's even easier. What's opposite of adding 6? Everything on one side. I get x less than or equal to, it's 4 minus 6, negative 2. So x is allowed to be anything less than or equal to negative 2. Is 3 less than or equal to negative 2? Is 2? 1? Is negative 1? Is negative 2? Is 0? Is negative 3? Yeah, there's just those two. Negative 1 is technically bigger, so Would you rather owe someone $2 or $1? And the -2 does count because it has that equal to part. Otherwise, it wouldn't. Okay, questions on that? We might have time for one more. Any last requests? Austin? On this one? 19. All right, so this is the one I just now remembered we were gonna do and then draw. Okay, so we want to select all of the equations and inequalities that can represent the constraints. Remember, constraints are limiting factors. Since we have to select all that apply, we are gonna check each answer. So this one has 3n less than or equal to 225. What did they say n represents? Number of people. So would it make sense to multiply the number of people by 3 and compare it to how much they have to spend total? That makes sense? I think so. Because it says that they want them to have a sandwich. No, 2 sandwiches for each person. So actually, I wouldn't pick that one. But so don't pick that one. N greater than or equal to 32. Does it say that she wants more than 32 people at this luncheon anywhere? So then I wouldn't pick that one. Because N is for number of people. Maybe if it was sandwiches, it sounds like they want each of the 16 people to have sandwiches, but that's not what that variable is. N greater or equal to 16. Yeah, we want at least 16 people, so we can have more, we can have exactly. Now this one is timesing by the S. S stands for number of sandwiches. Does that make sense? Because the sandwiches cost $3 each. And we want to stay under budget. So our budget is taking time. So that looks good. Would I do 2 less than 2n at all? So 2 times the number of people, and then I want my sandwiches to be less than that. Does that make sense? I say no. Because you do want 2 sandwiches per person, but you want that to tell you how many sandwiches to buy. You won't buy less than that amount of things. So I'd go with those ones. Right, and it is. So those 3. Pay attention to your options. Don't pick randomly. All right. See you guys tomorrow. Have a good day. Hi, Miss Medina.
How's it going?